So this video is about the section on weather instruments, how you go about collecting the weather information that you put into your weather maps. And the spec asks us to take a look at a range of aspects of the weather that you can measure. So we need the element or aspect of the weather, we need the device that is going to be measuring it, and we need the units. So you'll find that in your notes, there's your element of the weather, space for your units, there's the instrument, and then here's your step-by-step guide of how to use it. Why is that there? Because the key word here is to describe. You don't need just to be able to list these things. You need to be able to describe them and say a little bit more. So we've got 3 bullet points for each of them that'll tie into your SCE questions. Right, let's jump on in. So the first thing is the temperature, and the temperature is measured using a digital thermometer, and the units for it are your degrees C. Now here is your description of it. Inside these little devices you've got digital chips that are sensitive to the temperature. So the microcomputer inside converts this into temperature readings, and then this can be displayed. The current temperature can be displayed. This one also displays humidity, although you don't need that for the spec. The current temperature, or you could also be taking a look at the maximum and minimum temperatures reached over the past 24 hours. Okay, so if you want to pause the video here, and either from the video or from the slides, you can copy that into that first row. Right, this brings us to number 2. That's what it should say here. Number 2, rain gauge. I suspect maybe my numbering system is a little bit up the left, but we'll see anyway. This is your rain gauge, which measures your precipitation, and it measures it in millimeters. Here's a photograph of one. But just to make it a little bit clearer, here's what it looks like and what it consists of. A rain gauge has 3 elements. Up towards the top, you've got the funnel that collects the rain as it falls. It's held in this jar, and the rain that's funneled down goes into this measuring cylinder. Now you can see the measuring cylinder up the side. Now, one thing that's important about the location of this, it needs to be buried in the ground so that it won't fall down, but the top of it needs to be sitting about 30 centimeters above the ground. This is to stop the reading being affected by surface runoff and by raindrops splashing. So the rain, if it's particularly heavy, could splash into it if it wasn't high enough up, and if it was buried in just level to the ground, if you had surface runoff here, it would flow in as well and distort it. To read the value, you do this once every 24 hours. You go out and you take the measuring cylinder out of the jar, bring it up to eye level for the most accurate reading. Okay, you can pause this and add that into your notes now. This brings us to the third instrument, which is your anemometer. This measures wind speed in kilometers per hour, or sometimes in miles per hour, or sometimes even in knots. And it consists typically of 3 or 4 little cups like this that just catch the wind from whichever direction it's going in, and it spins around. The faster the wind, the faster it spins. So here's your description of it. The anemometer consists of those elements here. There's the cups that spin, as you saw in that little GIF before. There's your wind speed reading coming through here. So you take this out into an elevator, hold it up above your head, away from trees or buildings, because the trees might slow down the wind speed, or you might get a gust around the corner of a building. So away from places that could affect it, and you can see the photographer here has captured this in mid-spin, and there is the wind speed coming through there. You will then, third point, note and record the wind speed shown on the screen. Okay, you can add those into your notes now. This brings us to instrument number 4, which is your weather vane, and this measures wind direction, and it measures it in the 8 compass points: north, south, east and west, and the ones in between: northwest, southeast, that kind of thing. So a weather vane has a freely rotating arrow up at the top, and that just moves in the wind, pointing the direction of the wind. It's located at the tops of buildings. For example, we have one up here in the spire in Lurgan College. Again, just similar to the anemometer, you want to get it away from the effects of buildings and trees that could affect the wind direction. So you get it in a nice elevated position like that. It often is up there for decorative purposes as well, but it can function very, very well in those locations to record the wind direction. What you then do is observe the wind direction, observe the prevailing winds. There might be a few gusts and things like that, might just come from a slightly different direction for a while. So you just observe it for a while to get the prevailing wind, the most common wind direction. And again, you can record that. Okay, pause the video and make your notes. Number 5 is barometer, and it measures air pressure in millibars. Now, just a little bit here for you about what air pressure is. First of all, air pressure really is the weight of the air. So as you stand at sea level or stand anywhere on the ground, you have this column of air right above you all the way out to the edge of the atmosphere. And there is a greater density of air lower down and a lesser density further up. But the pressure of air on you at that point is the weight of air all the way from the edge down here. So that's the air pressure, it's the weight of the air. Now, how is it measured? It's measured in a barometer. A barometer has what's called an evacuated cylinder. It's basically just a cylinder with the air taken out of it, a vacuum if you like. So as the air pressure falls, the cylinder expands. There is less weight on it, so it expands out. Conversely, as the air pressure rises, now remember, pressure is the weight of the air, and there's more air pressing on it, so the cylinder is compressed. As the pressure falls, it expands. As the pressure rises, the cylinder is compressed. So this cylinder has an arm attached to it, which moves this dial, and this dial will move constantly depending on what the pressure is that allows you to get a record of it. Now, these kinds of barometers were very common in people's homes in the past, before we had access to the internet and constantly updated indication of what the weather was going to be like. And you could use this to get a sense of what the weather was going to be like. So this copper arm here had this little turning dial here. You could just turn that around over the top of the black dial as you went to bed that night. And then you could see the next morning where the dial had moved. If the pressure is falling, if you're getting lower pressure, that tends to bring less good weather conditions. So from that pressure, you could assume that maybe rain was on the way, and maybe if it was down here, it would be getting quite stormy. Conversely, if it went the other way, high pressure tends to bring good weather conditions. So if you'd set the bar there and the black dial had gone round here, you could get a sense that the weather conditions were going to be improving. Now, some people still use this today. This is a fine gentleman of a man. He was my head of department whenever I did my PGCE when I was just starting to be a teacher, long time ago. Mr. Wilson, he's retired, but he still loves being a geographer, and he has this at home. And there you can see that he has actually lined these two up just to get a sense of where they're at and where it's going to go next. But this is a storm that occurred in kind of winter of 2020, Storm Jorge, 960 millibars in Port Stewart. Storm Kira just before it was 965. Now 960 millibars is very, very low rating, and it takes you all the way around here. But there it is being used even today by my old head of department. Cloud cover is the last one, and this is done by observation. The units of it are oktas. You basically find an open area with an unobstructed view of the sky, so you need to be standing away from buildings and trees, and you estimate what proportion of the sky is covered in cloud, and you do this in eighths. So that's not the whole sky, but you could get the idea from that. What proportion would you estimate there is covered by that? Now you can see that's quite hard, but you would train your eyes. You got better and better, more practiced at it to see just how much of that would be covered by cloud, and then you record this reading in your record book. Now here's an example of how you go about using it here. This is much more simplified. Obviously that last one shows you how complicated it can be, but 1, 2, 3, 4, 5, 6, 7, 8, and you can see that 1, 2, 3, 4, 5 covered there, so you've got 5 oktas of cloud cover in the sky above you there. The last thing just to say about this is we'll come back to this when we look at weather maps, because we'll see that when we're looking at weather maps, these little symbols appear on them, which are showing the cloud cover, and they're showing them in those octaves and eighths, and those little pies and the little ways they're filled in allow you to read off this and see what proportion of the sky is covered in cloud. So there we go. We've got the temperature, which is measured by the digital thermometer in degrees C. Precipitation, measured by the rain gauge in millimeters. Wind direction, by the wind vane, the compass points. Wind speed, anemometer in knots. Atmospheric pressure, barometer in millibars. Cloud types we'll come back to later. And cloud cover by observation in oktas.